So that table on the next page just shows you some radiation weighting factors. Don't worry, I'll leave that up for a little bit. So if you've written that down, you can have a read through the examples and see if you can have a go at them, but I will go through them. Has everybody copied that up? Do I need to leave it up for any longer? Okay, right. So, note that the biological effect of radiation also depends on the type of tissue or part of the body that is exposed to radiation. Some types of tissue are more radiosensitive than others. Okay, so example 1. In a medical lab, a sample of tissue of mass 0.25 kilograms absorbs 5 times 10 to the minus 4 joules of energy from gamma rays. Calculate the absorbed dose of the tissue that the tissue receives. So first of all, read that question and write down what you've got. So we know that we've got a mass of 0.25 kilograms. We've got energy, and if you're not happy with standard form, please let me know. So energy is 5.0 times 10 to the minus 4 joules. And it asks us to calculate the absorbed dose. So we're going to use this equation. Absorbed dose is the energy divided by the mass. So 5.0 times 10 to the minus 4 divided by 0.25, which comes to 2 times 10 to the minus 3 gray. Okay, that one was relatively straightforward. Just find the correct numbers from your question. Example 2, a worker receives an absorbed dose, so remember absorbed dose is D, of 20 microgray. Remember I gave you that table at the start of the year. Micro is 20 times 10 to the minus 6 gray. We want to find the equivalent dose, that should be H, equivalent dose. And we're told it's fast neutrons. So the radiation weighting factor of fast neutrons is 10, looking at that table above. So the equivalent dose is the absorbed dose times by the radiation weighting factor. So 20 times 10 to the minus 6 times by 10. This is good practice putting standard form into your calculator. So that comes to 2 times 10 to the minus 4 sieverts. Okay, so the only real difficult thing about this is making sure you're happy putting things into your calculator correctly. Have a go at example 3. Oh, sorry, Jimmy. Sorry? So dose is 20 microgray. Yeah. Remember I gave you that little table? Have a look at that. Yeah. Okay, have a go at example 3. It would be 20 times 10 to the minus 5, which is 2 times 10 to the minus 4. Yeah, you could do 20 times 10 to the minus 5, that's fine. Yeah. Yeah, that's just what will come up in your calculator, because your calculator tends to simplify it to the most. So start with writing down what you know. So you have to work out which equation to use. You've got two choices, but you need to use the one that you've got the information for.
On my calculator, I can't include like -6. So like 10 to -6. I can't do that. I can only do -1. I can like.
No, so remember that special button I told you to use? Yeah. So if you want to put in 500 times 10 to the minus 6, you put 500, then and then just -6, so -6, and that's it. You done. Yeah. Yeah, it's important that you do. You can use your calculator using these, by the way. So if anyone is having any trouble, please let me know, and I can try and help you out with the calculator. So you should be using this equation. Equivalent dose is absorbed dose times by the radiation weighting factor. You can't use this one because you don't have energy or mass. Okay, so you should be saying the equivalent dose, H, is the absorbed dose times by the radiation weighting factor, is alpha, so the radiation weighting factor is 20. So 500 times 10 to the minus 6, because it's microsieverts, is the absorbed dose times by 20. So the absorbed dose is going to be 500 times 10 to the minus 6 divided by 20, which you should get as 2.5 times 10 to the minus 5 gray. You'll make sure you are getting that correct answer in your calculator. If anyone isn't, please let me know, because it's probably just something you're putting into the calculator wrong. You don't get it? If you're using the phone calculator, they're not the most reliable when you're putting in times 10 to the minus 6. Show me what you're doing. Yeah? No, you don't need to do times. Remember, it's the X button. Yeah, that's what you're going wrong. Where you're going wrong. If you do times 10, it will add on an extra 10. How about guys at the back? Are you getting the right answers? Minus 6. So remember, let me get my finger again. You're the only one, but you're the only brave one to ask. So, on your calculator, you should have. Just wait till this goes. There we go. Right. So you should have a button here. It might say E, it might say X, it might say times 10 to the. So that's your important button. So if you want to do 500 times 10 to the 6, you do 500, then this button, then minus 6. And then that's you put it in. So you don't need to do times, or you don't need to times anything. All you do is 500, that button, then minus 6. Yeah? That's probably relevant for a few people. Okay, so, yep, Jim. Yep, I'm going to go through that one, because you'll need to do it separately, basically, and add them together. Is everyone happy with the calculator before we move on? Because I do want to make sure you're all happy with that, because I guarantee there'll be a few people. Right. Okay, are we all good to move on to number 4? Okay, right. Number 4 is, as Jamie pointed out, there's 2 different things, so we have to split it. So we've got a tumour is given an absorbed dose of 100 microgray of alpha radiation and an absorbed dose of 600 microgray of gamma radiation. So we've got 2 different radiations. Calculate the total equivalent dose received by the tumour. Okay, so we have to look at alpha. So alpha, remember that's the symbol for alpha, and gamma. So the equivalent dose is the absorbed dose times by the radiation weighting factor. So the absorbed dose of alpha is 100 microgray, so remember 100 times 10 to the minus 6, times by the radiation weighting factor of alpha, which is 20. So that comes to 2 times 10 to the minus 3 sieverts. And we need to do the same for gamma, which radiation weighting factor is also 20. So H equals D times WR. And the absorbed dose for gamma is 600 times 10 to the minus 6 times by 20. And that comes to 0.012 sieverts. To find the total, you just add them together. So please make sure, once you've written this down, have a go at doing it on your calculator and make sure you are getting the same answer as me. It's really important you practice with the calculator now rather than coming to do it in a test and going, I can't remember how to use my calculator. And if you've done that and you checked with your calculator, read through example 5.
And why is WR20? Is that just like...
So if you look, the page here tells you the mole. So the radiation weighting factor for alpha is 20. Oh, there's 1 here. Oh, sorry, yep. I must have misread it. I was completely wrong there. Sorry guys, that's probably why you're getting the wrong answer. Oh, it's 20. Right, okay, we'll leave it then. Well, whatever it is in your booklet, keep it to whatever's in your booklet. So if it's 20, I'm assuming everybody's is the same. Has everybody got 20? Okay, we'll leave it then. For gamma as well. For both of them. Yeah, 20 and 20. Let's check. Yeah, it's 20, good. Okay. Right, everybody getting the right answer? Anybody not getting the right answer and don't know why? Okay. Last one. A worker finds that... Sorry guys, are you okay? You get it? Good. A worker finds that at the end of the year, she's received 50 millisieverts. So milli is times 10 to the minus 3. The maximum permissible equivalent dose. She's worked 40 weeks in the year with an average of 20 hours exposure to radiation per week. What average equivalent dose per hour has she experienced? Right, So this one's giving us a lot of information. So her total equivalent dose, that should be it, is 50 millisieverts, so 50 times 10 to the minus 3 sieverts. I've just put HT just to signify the total. We want to know what her average equivalent dose per hour is. So to work that out, we need to know how many hours she's worked. So she's worked 40 weeks, 20 hours per week. So 40 times 20, which is 800 hours. HT means total. You can write total if you want. So to find out the equivalent dose per hour, we take the total equivalent dose and divide it by the number of hours worked, which is 6.25 times 10 to the minus 5 sieverts. Again, try it with your calculator. If you're not getting the right answer, please give me a shout and we can work out what's going on. And the average background equivalent dose in the UK is around 2 millisieverts. Sorry? Yep, good. Do we need some practice with prefixes, guys? Do we think? Yeah, you do need to know them, yeah. Tell you what, over the weekend, just have a read, you know that little sheet that I've given you? If you're missing it, let me know because there's some spare at the front. Over the weekend, read over that and then we'll sort of recap prefixes on our next lesson on Monday, okay, just because some people will be happy with them, some people might not, but want a bit of a recap, so I'll recap it a little bit. Okay. Right, so, but for now, what I'd like you to do is questions 40 to 50, 60 to 65, or on this kind of thing. Okay. And please do shout me if you're confused with your calculator or anything like that.